Hello guys, welcome back to Matematika class. Today, we will discuss the second topic of division of polynomial. We have two other methods, comparing coefficient and scheme method. So, we have learned the first method of long division with all these long ways. Maybe you found that this process is quite long and sometimes contain many errors. So, we will offer you another method to confirm the process of division. Before that, let's check some notes first. The result of the division may be stated as an identity. Dividend, which is the function, is the divisor. In here, the divisor is x minus 2. Multiply with the quotient. In here, we have the result of the division 2x cubed plus x squared plus 3x plus 6 and added by the remainder. In here, the remainder is 13. Usually, we abbreviate it as fx equals dx times qx plus r. Yeah, please remember dqr. Then, please notice that first, the division stops when? Do you know when? If you see the relation between the remainder and the divisor, the degree of the remainder is less than the degree of the divisor. So, maximum degree of remainder is degree of divisor minus 1. If in here the divisor is with the degree of 1, or a linear divisor, so for sure the remainder is a constant with the degree of 0. Note number 2, the degree of the divisor added with the degree of quotient will be equals the degree of the dividend. So in here, we have the degree of the divisor 1 added with the degree of the quotient 3, and 1 plus 3 is 4. That's the degree of the dividend. The second method is comparing coefficients. Let's try to divide 2x to the power of 4 plus x cubed minus 3x squared by x squared minus 1. Using this method, we need to perform this division in identity. So, this is our function, and let's have our divisor x squared minus 1 so that the quotient is in degree 2. Why it is in degree 2? Because the result have to be 2x to the power of 4. Next, since the degree of the divisor is 2, then we have the degree of the remainder which is 1 less than, so we symbolize as ex plus f. So in here, having the quotient in the form of ax squared plus bx plus c or a quadratic and having the remainder ex plus f, we can have all of the multiplication to be the same left and right. First of all, in here, at the right side, we have the first multiplication of x squared with ax squared, which produce ax to the power of 4. At the left, we have the coefficient of x to the power of 4 is 2. So we can conclude that a is 2. Next, for the coefficient of x cubed, x squared is multiplied with this bx. Produce bx cubed. At the left, the coefficient of x cubed is 1, so that we can conclude that b is 1. Next, the multiplication of x squared with c that produce the degree 2. Be careful that we also have this multiplication of minus 1 and ax squared, so that the coefficient of x squared at the left, which is negative 3, is the result of c minus a. We substitute a is 2, so we obtain c is negative 1. Next, for the coefficient which produce x, we have minus 1 and bx, and don't forget we add it with the EX in here, so that the coefficient of X, which is 0 at the left, is minus B plus E. We substitute B 1, so that E is also 1. Last one, for the constant, it is coming from the multiplication of minus 1 and C, and also F. So at the left, 0 is minus C plus F. So we can calculate F is negative 1. So that the QX, which is AX squared plus BX plus C, can be substituted become 2x squared plus x minus 1. And for the remainder, with the degree 1 here, is x minus 1. So that's how you use the comparing coefficient. Let's have another exercise later. Next, for the third method, is called the scheme method or HORNER way. So in here, if you are using HORNER way, you have to define whether your divisor is linear with the coefficient of divisor is 1. Second, is it a linear divisor with coefficient of divisor not 1, quadratic divisor which can be factorized, or quadratic divisor which cannot be factorized. So if you are using method 3, you have to define all of different divisor and use correct way for each divisor. What we will discuss now is how to use HORNER way for linear divisor with the coefficient of divisor 1. This first type. So, suppose 2x to the power of 4 minus 3x cubed plus x squared. In here we have the coefficient of x is 0, added with 1, divided by x minus 2. So using HORNER way, we will take out all of the coefficient from the function and list it in here below the correct variable. So we have 2, negative 3, 1, 0, and 1. So in HORNER way, don't miss any coefficient with 0. You need to still place it in the correct place, so it is in order from 4 to 0. Next, for the divisor x negative 2, take out the zeros of the divisor. So x negative 2 will be equal 0 when x equals to 2. So we take 2 here, and this is the zeros of the divisor. So the first way using HORNER is you put down the first coefficient, and the next step is you multiply it with the zeros of the divisor. 2 times 2 is 4. Next, you will add it with negative 3. Produce 1, and after that you repeat the same pattern. 1 times 2 is 2, 1 plus 2 is 3, 3 times 2 is 6, 0 plus 6 is 6, 6 times 2 is 12, and 1 plus 12 is 13. So, you remember this remainder? Yeah, we obtain the same remainder for the process that you will see in long division, and we got our remainder. 2, 1, 3, and 6 is the constant of the quotient with the degree of the quotient is 1 less than the degree of the remainder, so that the quotient is 2x cubed. Since it is degree 4, then the quotient will be in degree 3. 2x cubed plus 1x squared plus 3x plus 6. So this is how you find the quotient and the remainder using the HORNER way or the scheme method. Okay, so please take a note in here. What we learned is only the HORNER way with the degree of the divisor 1, and when it is greater than 1, we still have another steps of HORNER, and later you need also to reform the remainder. If the divisor is with the coefficient not 1, later we will talk about it as well. Okay, So, that's all for today. We already learned 3 methods of division of the polynomial and how you can state it as identity. Let's continue with the exercise at the meeting. Keep healthy everyone. See you soon. Bye-bye.